Hello, everyone. Welcome to our live stream tonight. Thank you so much for being here. We've got a very fun show for you tonight. First order of business, I am solo. I'm by myself. So Kate's not able to make it, and just kind of a last minute thing, but we're going to move on with the show anyway. So please bear with me as I get through some of the things like the giveaway, upcoming later in the show, or some of the slides and actually images of customer examples I want to show later on. So hello to everyone. See some familiar faces in the chat. We got Greg, Dan, Lawrence, Michael. It's going to be a really good show. So thank you all for being here. Like I said, for those of you who are new here or don't know me, my name is Jace, and our business is AirWeights. AirWeights is a modular vacuum table solution for small format CNC machines. Kind of 4x4 is our sweet spot. A lot of the prosumer designs we end up supporting for work holding. Got a variety of different products to serve as many customers as we can. And if you're interested, please check out our website, airweights.com. So if you have not done so already and you're watching this video, please subscribe to our channel. We're going to be putting out a lot more content. It's going to be a big focus of mine personally to start providing more resources for customers and more education, more learning, more examples, so that you can get the most out of your AirWeights product line and our product line. If you're interested in new product announcements, things we're doing, things happening around the shop, blog posts, things like that, please also subscribe to our email list. If you go to the very bottom of our website, there's a little bar at the bottom of any of the pages on the website where you can type in your email and subscribe, and that'll keep you up to date on any sales we're running, the best deals that we have, best information that we have. So please check that out, and that's a really good way to stay connected to AirWeights and see what's coming and what's happening. So outline for tonight's show, the whole topic is no tabs. This show tonight is about all the different methods that we have for completely cutting through your part, leaving a finished part when you're done with your machining process. So we're going to go through all the different ways the AirWeights ecosystem allows you to do that. You know, Spoilboards, fixture plates, different types of gasket, and kind of outline the entire gamut of what's available to you to achieve finished parts. And then also, of course, there's a few things that you want to consider when doing that and appropriate approaches for different styles of parts. We'll also look at some customer examples, things that people have done and done successfully with our products in their own shops. So it's not just me talking about it, it's actual real world examples of people out there making stuff. So that'll be exciting. We have some products that are back in stock that I want to touch on later in the show. We also have some new bundles, which are really exciting. They're pretty heavily discounted, so I'm pretty excited about where those are going to go for our community. We'll do our standard question and answer session, so live Q&A. If you have questions, please put them in the chat. The thing I'm going to tell you right now is it's going to take a little bit of time for me to go through and filter those questions just because I am solo here. But bear with me, and I'm sure I'll be able to get to all of them. I'm usually pretty good about questions. Later in the show, we'll have a giveaway. We're going to be giving away a 24x24 complete system. We've done this for every single live stream that we've done. So I really hope that somebody who needs this system gets it. If for whatever reason it's not the system that you need, not the right form factor for your machine, you want something else, we will give you, whoever the winner is, a credit of equivalent value towards whatever system you would like in our entire product offering. So pretty big deal. Text your friends, tell them to come and come win a system. And then after the giveaway, we'll wrap up our show, and that'll conclude the evening for us. So once again, thanks for being here, and please subscribe to our YouTube channel if you have not already. For the show tonight, of course, we're going to offer a sale. So if at any point during the show you see something that you would like, you can enter NOTABS10, that's NOTABS 10, as a discount code, and you'll get 10% off any product in our entire product line, no minimum, and that should help you out a little bit with making the leap if you're interested in purchasing an AirWeights system. So the topic, I'm going to jump right in, is no tabs. So why do we care about eliminating tabs or onion skin or clamps? And there's a variety of reasons, and I think some of the most important things to mention are just first the general experience. When you have to leave your finished part attached to your stock, it takes time and energy to separate it from the stock, cut the tabs, go to a router table, flush trim, sand. Sometimes, flush trimming isn't quite as accurate as the CNC, so you get a little offset and there's a little bit of an edge defect that you need to sort of, work out. So a lot of reasons to avoid tabs. Another reason is basically with vacuum work holding, you can nest parts extremely close to each other. You don't have to have excess material to hold the material down in place with clamps or screws, things that you can't machine. And then, obviously, you can go down the path of tapes and glues. Totally works. There's plenty of methods out there that do that. There's some great products out there as well. It's just that if you're in an environment where you're starting to produce a lot of volume, that gets pretty old pretty fast. Peeling stuff off the backside of parts, and also having the limitation of sometimes jiggle or wiggle in the part. So there's a lot of reasons why we want to start to get to a finished part at the end of our machining process to optimize throughput, and especially if you're running a business or running your CNC pretty often, this really starts to lend itself well to the prosumer user, the heavy user, the someone starting a small business. And tonight we're going to go through all the different ways that you can get rid of tabs, onion skin, other work holding methods, and just use vacuum. So we're going to describe and demonstrate several of those approaches. And the final approach that I mentioned, I'll actually run a live cutting demo for one of our new products that's coming out that's been requested a few different times. And it's one of the accessories for that product, but it's a great example of using one of the particular approaches that lets you cut all the way through and leave a finished part when you're done. So the very first approach that I want to talk about today that allows you to cut completely through your part is just simply a bare spoil board. Now, AirWeights products leverage a type of vacuum pump that produces very deep vacuum and less flow rate. So we're trading flow rate for vacuum and a depth of vacuum level. And with that, there's some differences between our systems and traditional vacuum tables in the industrial sector, which use a tremendous amount of flow rate and don't always get to very deep vacuum. So some of the nuances of our product differ from large industrial systems, and that's okay. That's by design, that's intentional, and it allows you to leverage a smaller pump to achieve really incredible work holding results in your home or in a small business or in a small shop without need to access a ton of power, having something really loud, etc. So I mentioned that because a bare spoil board for us is very specific. What I mean by that is there are requirements for the type of MDF that you should use for a spoil board on top of an AirWeights system. If you're interested in what a spoil board is and how they're used with our products, you can check out our previous live stream. We covered it in a lot of detail. But I'm just going to do a quick demo right now to show you what it's like to hold material on a spoil board by itself, no gasket material. It's just a 1/4-inch sheet of MDF that we sell. And that MDF is pretty particular. If you've watched previous streams, you know this. We use a material called Medex MDF. I feel like I beat this horse to death, but I'm just going to say it again. It has a very specific and very consistent density. And that plays well to the type of vacuum pump we use, being that it pulls deep vacuum. It restricts the flow enough to provide adequate work holding for smooth, flat, non-porous parts on top of a spoil board directly. So let me just demonstrate quickly what that looks like and the expected results you can see. So I have a piece of, this is Bamex plywood sold by CIC Workshop. I'm not an affiliate, but the stuff's pretty amazing material. In one of our videos recently, we made a little cruiser skateboard out of this stuff, so you can see that kind of arc that's cut through there. That's half of the outline of the board. And what I love about this material is that it is those things: smooth, flat, and non-porous. Smooth, flat, and non-porous. And it has a nice thickness to it. It's 3/4 inch. And what that means is that the contact between this surface and a bare piece of MDF, especially with this big of a piece, this much area, is going to be really good and achieve really good work holding support. So what I'm going to do is I have my, I don't know if you guys can see down here, I have some manifolds here that allow me to shut off individual zones of my vacuum table. Right now, I have these 2 front zones set up, and they're both on. They have spoil boards on top of them that are located with pins. And that allows us to put the spoil board back in the exact same XY position relative to our vacuum table and all our previous programs, which can be helpful in certain situations. So I'm going to turn on my pump and seat these tables, and then we'll see what kind of work holding force we get with this piece of Bamix right here. So the pump goes on, and I'm just going to make sure that this is seated everywhere. I can feel right now that we're starting to get good hold. Yep. So here's my piece of Bamix. If I place it on here, it's a little bit hard to tell from the audio here, but I can hear the tone of the vacuum pump actually change as it pulls a little bit deeper vacuum. And that's reflected on the gauge. And once this thing is on, I can put my entire body weight into pulling this thing to the side, and it's not going to move. And again, the reason for that is the material is smooth, it's flat, and it's non-porous. If you have something that's warped, bowed, twisted, coarse grain, not very hard, kind of soft, it's a lot harder to put on a bare spoil board unless it's something like a gasket material. So I'm going to shut the pump off now. And if anybody's wondering, I'm running a 17 CFM pump under here. And again, that's 2 zones active, so a 24 by 48 area with two essentially bare spoil boards on it. So I can just take this off now that the pump is off, and that is a method that allows you to cut all the way through. The caveat is you need a lot of area, and like I said, it needs to be smooth, flat, and non-porous. So you can put this on here, cut out large shapes. I can do some other tests for you really quickly to demonstrate kind of the limitations. But a bare spoil board is really for those larger pieces. If you're making, you have pre-finished plywood and you want to cut out some cabinet doors, that's a really nice size for that type of work holding approach. I can hold about a 12 by 12 piece of material if it meets those smooth, flat, non-porous requirements pretty effectively with this. In fact, this is a 12 by 12 fixture plate, which will be an example part later in the show. And if I turn this back on again, and I just seat the gasket, let it get to vacuum, I put this on here, it's also very rigidly held. So, lateral force is extremely high, but if I wanted to, I could just simply peel up the corner and burp the seal. So that's about the limit of what I would recommend with a bare spoil board using our system, about a 12 by 12 part, or having enough coverage that you're completely covering the spoil board and there are no leaks except for where you're cutting through. You can do some pretty interesting things with that as well. So that's sort of the bare spoil board approach. Smooth, flat, non-porous materials, large parts, really nice intimate contact with the surface of the MDF, making sure that you have rigid work holding with that big size smooth part. So the next thing, that's not always the case. Like when you're a woodworker, that wood is not always going to be smooth, flat, and non-porous. Like if you happen to be in an industry where you're machining plastics all the time, or you're running pre-finished plywood all the time, or you have these really nice materials to work with, that's great, but that's not always going to be how it is in the real world. So we need some other solutions that allow us to cut completely through while still providing the same experience as a bare spoil board. And that's where tile gasket comes in. So tile gasket is another material that allows you to cut completely through your part. It's a perforated foam rubber sheet sold by All Star CNC Products. We resell it, and we also provide it pre-applied to our spoil boards so that customers can simply place it on their vacuum table and begin machining as soon as they are set up and running. So the same sort of principles apply. Flat and non-porous for sure, but it doesn't have to be quite as smooth. The stock can have a little bit more variance, a little bit more grain, Typical like birch plywoods are a good candidate for this as long as you have enough part area. Down below the 6x6-ish size, it starts to get a little bit tricky, but there are some things you can do to cut parts that small if you're really into this. The key with tile gasket and with spoilboards for that matter is to maintain a very accurate depth of cut. So you want to control your Z heights very precisely so that you can preserve the service life and maintain the integrity of this surface for the longest period of time possible. So it's less forgiving, but it gives you the experience of universal work holding. You put the piece down and you cut it out. So I'll demonstrate that very quickly, but it's the same sort of approach. So if I take this spoilboard off and put the other one on, and if you're wondering, all of our vacuum tables come marked with this little mark on them that says this side down, or vacuum tables, all of our spoilboards, so that the customer knows which side goes down if you were to buy a bare spoilboard. Obviously, with a pre-applied sheet like this, tile gasket always faces up, but if you bought a bare spoilboard that you wanted to, say, skim 5 or 10 thou off first before you apply the tile gasket, you can tell which side is meant to go down, and that's just for if the 1/4 inch MDF has any concavity to it, if it's bowed a little bit, which tends to be a thing with 1/4 inch sheet goods in general, but MDF also. So you're looking for to have a concave down piece, and then you can just push in the center and it'll form a seal around the perimeter. So that's why we do that, just FYI. So I'm going to place this on these pins, and it'll locate in this same spot every time. And I'll turn this on again. And something to note is that my vacuum reading is now deeper. And the reason for that is because I have this sheet of tile gasket on the MDF. All that surface area that was previously leaking is now no longer just leaking to atmosphere. Air is being forced through all these little holes in the tile gasket, and in effect, making each one of these holes like a little super suction port. So now if I put a piece of material down on here, again, I think if I put this down, I won't be able to get it back off without turning this off, but yeah, so now, you can almost pick up the machine, slide it. So very rigid. And this time, I don't think, you can't burp the seal on that. So if you had something that had a little bit more grain to it, that would be, a good application for tile gasket. One of the main things, though, with any of these approaches is making sure that you're covering as much surface area as possible. Tile gasket and spoilboards, used bare, are really meant for processing sheet goods. That's how this whole work holding method was developed for the cabinet industry. So you want to think about, if you're using a spoilboard or a spoilboard with tile gasket on it, think like processing full sheets, half sheets, quarter sheets, some big piece. So that's the goal. And again, the more area you have, the stronger the hold down force, because it's just the pressure times the area, the pressure difference times the amount of area you have. So the next method that allows you to cut completely through on a spoilboard in particular is using what we call an onboard gasket approach. So All-Star, who makes tile gasket and is one of our partners, also sells a variety of different other gasket solutions that allow you to make a sealed zone of negative pressure underneath your part. And the key there is you want it to stay underneath your finished part, not just your stock, but the finished part that you're fabricating. Then if you cut through outside of the perimeter of that seal, you maintain the same work holding that you would, regardless of where the seal is. So if you look under this spoilboard right here, in our last live stream, we did a quick demo where we made 3 pin holes, put pins in, and created a corner reference for machining this, a little piece like this. So on top of the spoilboard, I've just stuck down one of our nested gasket squares. And those are die cut in a set that go from 12 inches, outer dimension, down to 11, 10, 9, 8, 6, 7, down to 4. And 4 is the smallest, and we sell a set of those. And you can simply peel off the backing, and it's adhesive backed, and then you just stick it on to a Spoilboard or a fixture plate, and it allows you, to cut completely through and provides much more rigid work holding on your workpiece. One caveat with this is just to make sure that if you're using very thin sheet stock, you might see some sort of bowing in the center and the unsupported span. So you can take either other 16th inch thick gasket material to provide some bridges or supports in there, while still maintaining an open cavity. Or if your material is thick enough, it just doesn't really matter. There's no bowing because the material can resist how much downforce is being applied by atmosphere. So again, I'm going to turn this on, and we'll see that if I push this down, so I can hear the vacuum pump change in tone again. I can see my gauge is going deep. If I put this just, here, I can pretty much slide it around really easy. This is not enough work holding area. It sticks a tiny bit, but there's no way that's going to stay in place when I start machining. If I put this against these pin references and then place it down, that little zone that's sealed off by the gasket underneath there is now creating a much larger pressure difference above and below the part. And so for that amount of area, now if I push, it's extremely rigidly held. So, if you're doing one-off quick setups and you want to have really rigid vacuum clamping on a Spoilboard, you can use an onboard gasket zone, either by buying a strip or a roll form of it that's a 16th inch thick by a 1/4 inch wide, or you can use these nested gasket squares, throw one down and put your walnut board, maple board, hardwood board, whatever it is, right onto that piece, do your processing, cut all the way through. And in this case, there's actually a tiny little gap underneath the board between the workpiece and the MDF. And that actually allows you to cut completely through without even touching the MDF. So kind of a cool feature if you're really accurately controlling your depth of cut. So shut off the pump again. So an onboard gasket approach with MDF is another way that you can cut completely through and leave a finished part. So quick and easy, and something that I think is pretty under-leveraged by our whole community. So it's very simple, it's very effective. The only downside is that you still have quite a bit of aggregate leak. So you don't get quite to the depth of vacuum that you would with one of our fixture plates. And fixture plates are essentially like a non-porous Spoilboard. So you want to think about them like, a piece of plastic material, same material as our vacuum tables, that sits right on top of the vacuum table and provides, again, that sacrificial surface that sits between your workpiece and the vacuum table. And that sacrificial layer is what allows you to cut completely through, regardless of what material it is or what type of approach you're using. So our fixture plates are, the only difference is now you need to, since they're non-porous, create a port, a connection that goes between whatever vacuum zone you make and the vacuum table underneath. Otherwise, there's no air being transferred between the two volumes. So I'm going to remove these Spoilboards from the machine, and I'll place a few fixture plates on here, and we'll talk through some of the approaches with those. So I'll take this piece off, and I'll remove these pins for our corner reference. And I'm just going to stack these guys put those away. And then I'm going to place 2 fixture plate examples on the machine in those positions. So this is kind of highlighting the modularity and ecosystem of AirWeights, meaning that I can switch between a Spoilboard and a fixture plate in literally moments while I'm talking to you and explaining a bunch of stuff. So this is a fixture plate that I've put together a long time ago. And that's the other thing about them is once you set them up, you can relocate them in the same position, and then you have the same set of programs based on the same work holding or work coordinates or offsets, and you can run the same program over and over again. So there's a little bit of work to set it up, but once you do, it really pays dividends down the line, especially for production work. So let's get this guy on here. And these are two demonstrations of effectively the same thing. So two different ways, and benefits and drawbacks to each, depending on what your application is and how much you care about certain tolerances or accuracies. So on the left side, I should probably just pull this off and show you. On the left side, I have a fixture plate, and this was a very quick and easy thing to set up. I just took the fixture plate and I ran a file to see where the part would be. And I put my gasket just inside the perimeter of that. And if it doesn't have to be perfectly aligned with the exterior here, just like this. You could have it offset in a little bit and kind of close enough, and it would be just as good. As long as your seal is inside the, anywhere you're cutting all the way through, you're good. So all I did is I stuck down some strips of our onboard gasket on the top of the fixture plate, and I drilled a hole in the center, and that connects the pressure, the vacuum pressure from this little volume down to the vacuum table underneath, and the workpiece just sits floating on this gasket. Because it's only a 1/16 of an inch thick, by the time you compress it, there's very, very little movement. It's very rigidly held. And the only caveat, you're paying for a little bit of accuracy in your Z height because you're floating on a gasket for the ease and simplicity of setup. So really good for quick projects, especially things where you're just cutting all the way through and you don't care so much about the thickness of the material or the thickness of your finished result. So I'll put this on here again. And, if I, let's see, shut this guy off and then take a workpiece, turn on the pump. Right now I can hear this thing just sucking through this. You can probably hear that. We'll put this on here. Pump changes tone, and that thing that's never coming off. So, something that I think is really important to note about this is, I have one position set up on this particular fixture, but if I was making, say, 6 of these, I was making these widgets, pieces of wood or whatever in volume, I could have 4 at a time, 6 at a time, whatever I can fit onto a single fixture plate and run them in batches really, really easily. So again, a little bit of time to set up, but once you do it, it's easy. So I'm going to burp the seal with a pressure release valve and then simply remove this. So on board for a fixture plate, cut all the way through. You could see on that fixture when I was showing you that there was a mark where I had cut all the way through into the material. This part was actually processed on that fixture in the previous live stream, so you can check that out if you want. And then, this is another approach that is actually my favorite. Actually, before I talk too much about that, I should mention that there's another sort of permutation of onboard gaskets, and that's using a material called cover gasket. And cover gasket is very similar to tile gasket in that it's a foam sheet, but it has no perforations. It's a solid continuous sheet of 1/16 inch thick gasket. We sell them in 24 by 24 or 24 by 48 sheets. And that's an incredible tool for very small parts manufacturing, or if you're nesting a ton of parts into one setup, into one fixture, and you don't want to spend the time to individually gasket all these little zones manually. You can actually apply cover gasket. You take your fixture plate, put it under vacuum, face it just minimally to make sure that your Z heights are all level and trimmed and you're all good. Then you stick down this cover gasket and you take an engraving bit and you cut out the shapes of all of your different vacuum zones, your little gaskets, and then they're continuous. There's no splice or anywhere to try and connect them. It's a perfectly sealed vacuum zone. And then you remove all the excess gasket that you don't want, you're just left with all these, these individual zones. Put a hole in the center of those, make sure you're connecting to the grid underneath and the vacuum table as best you can. And then you place down a sheet of material or your stock material in whatever size increments you have, run your program, and you didn't have to go through and individually gasket those yourself. Your machine did the work for you. And so that's a really common approach where there's a lot of small, intricate, detailed parts. And I actually have some customer examples of that I'll show later. But cover gasket is basically the same thing as onboard gasket. It just has an extra layer that you can use to create your own gaskets using your machine, as opposed to having to roll out a roll and make a strip in a particular pattern to match the profile of your part. So that's a really nice feature, especially if you're making very small parts on the order of like 1 to 2 inches, like 1 by 2 square. We'll see some examples of that in a little bit. So the final approach that I want to talk about today, and the one that we'll actually demonstrate in the demo I have set up behind me, is what we call an inboard gasket approach. So in this case, I'm using what we call adhesive gasket on our website. It's adhesive backed, it's 1/8 thick, and it's 1/4 inch wide. And it's actually the same material that's installed around the perimeter of our vacuum tables. When you receive it, there's a pre-installed seal. And that material is really great for recessing into a channel. So you can see I've got basically a little vacuum table made right here. I have a seal that goes around the perimeter and then this grid pattern on the interior. And that's just to help promote airflow between the volume in between the seals. I have a port in the center that connects to this little volume, and when I put a piece of material on here, the advantage is that now my workpiece gets sucked flat against a reference that I machined. I faced this thing on my CNC, and so when it gets sucked down, it's going to be in the exact Z height that plus or minus whatever the tolerance on your machining operation is, but the pretty darn precise Z height that it was machined at. So you have a very stable reference if you need to make something that's exactly 3/4 of an inch thick or exactly 5/8 of an inch thick. You can use the top of the fixture as your 0 and then say, okay, I'm going to cut at 5/8, and boom, face right there. So really, really great approach if you're doing intricate parts that require a greater level of tolerance and control, especially on Z. So if I put this down, the other thing that I should note is the material that we use is very specific, and it's very important that we use this material. Also partially, not just because it's vacuum tight and cost effective and all those things, but because it provides a very nice friction coefficient between the workpiece, general workpiece materials, and the material that we're touching. So in this instance, by facing the material, we get an increase in friction between the base material and the workpiece, which is another advantage and provides extremely rigid work holding while also maintaining very precise depth of cut. So let me put this back on here. I lost a pin, but I think we're just going to roll with it. Someone's probably yapping at me for rolling with this, but that's okay. So now I'm just going to shut off this position 1 right here. Shut that off, turn the position 2 on. I'll turn on my pump. And again, I can, you can probably hear this. If I put a workpiece on there, it's going to get sucked flush to the table. You can hear the tone of the vacuum pump change. We're pulling very deep vacuum now. And of course, you guys have seen me pull on parts enough now. It's not going anywhere. So we'll release pressure and remove the part. So, dedicated fixtures are an incredible way. Dedicated vacuum fixtures are, in my opinion, the best way to operate a CNC for business or for repeat production of anything that you're making. It's just, it provides so much flexibility. You can customize them with reference positions, locating fences. There's all sorts of different things that you can do to really make them work for your application as optimally as possible. And so I really feel like, the two things that I think our community underutilizes are onboard gasket and inboard gasket approaches like this. If you're going to run hundreds of something, take the time to set up a vacuum fixture. You will be so glad that you did put in the few hours to make sure it's working. We had a local customer come by recently, just yesterday. I think it was yesterday. Came by yesterday, emailed me today, went home, set up his system, put a fixture on there. And he's actually one of the examples I'll show. The first one made an onboard gasket fixture and is already making parts and improving his production through time because he's cutting all the way through, leaving a finished part at the end. So let's actually demo that. Let's take a look at what it looks like when we process products using an inboard gasket approach. So I have a little bit of explaining to do, bear with me. Behind me, you can see that I have those two vacuum fixtures that I had placed here previously. Behind that, I actually have half of our 24x36 fixture. And again, this is one of the amazing things about vacuum work holding. 24x36, we end up with an offcut if we're processing half sheets of material. So at the back there, I decided to make little zones for 12x12s. And that's a new product that I'm teasing right now that will be coming out. It'll be incredible for benchtop applications or smaller machines, things where you just want to have a vacuum clamp, vertical work holding, things like that. It'll be, I think, a really amazing addition to our line. And of course, it's been requested a couple times, so something I'm excited about making, but not quite available yet. Again, if you want to be first to know about that announcement, or if you're interested in pre-ordering, you can send us an email, but please make sure you subscribe to our email list through our website. Again, bottom of any page on our website, you can subscribe there, and you'll be the first to know about that product. So what we're going to demo right now is actually cutting out our fixture plates for our 12x12 size. So before the show, I ran these, and I have little, individual vacuum zones back there, and they allow me to cut completely through on the perimeter of this, drill these holes for repeat locating on the 12x12, and there's a fixture plate. So we're going to run a demo of that so that you can see the benefit of running production using a dedicated vacuum fixture with the inboard work holding approach. So inboard gasket, the good thing about this is that I know that my Z height for my material is going to be the same every time if I zero off of the fixture. In other words, regardless of how thick my material is, which in a lot of applications tends to vary quite a bit, I know I'm going to cut through by the exact same amount every time. So I don't really care if I'm cutting an extra 30 thousandths or 40 thousandths or a 16th on the first pass, but having really accurate depth of cut on the final pass where you go all the way through the material, or if you're going through in one pass, just making sure that you're cutting through by the same amount every time is important. Because if your material thickness varies and you're probing from the top of the material, you're kind of blind. You don't really know, you're depending on the thickness of the material. And if you're running production, that's really a pain to have to constantly adjust for. So again, inboard, same Z height every time, totally dialed, load and go. So let's do that. Let's load. So unload these guys. Got a few pieces of material here somewhere. Okay. So I got two pieces that are 12x24, and I'm just going to stick these on. And since I've ran this once, I can actually see in the fixture exactly where I cut through. And I'll be cutting through by the exact same amount this time as well. So no question about where I need to position this, as long as I'm overlapping these grooves that are cut into the fixture right now, I know I'm going to be good. So see there and there, I'm overhanging everywhere. I know I'm going to cut it, cut the complete profile with the machine, which is important for accuracy of CNC parts. And then same thing here. I'm just going to push this in. So ideally, I'd have a longer piece of material, but you get the idea. That one's quite a bit bigger. Let's see if I can adjust the other one. So I got my material on. Happy with the placement. I'm going to adjust my manifold so that the back two tables are on, which energizes that fixture. You might be able to tell I have some plugs in the fixture as well for the front portion that cuts, that section of or holds that section of our 24 by 36 size. And so my front two tables are now off. And if I turn on the pump, I should expect this thing to suck down nearly immediately because smooth, flat, non-porous, inboard gasket, all the things. So I have my release valve open, but if I close that, straight to deep vacuum. So right here, thing is on there. Always want to check your work before you run any demo or live demo or program just in general. So we've had tons of feedback saying always leave the audio running when you run demos. So I'm going to do that. You'll get to hear it. It's not anything exciting. But let's run our dust collection and get this thing going. I've already measured the tool, tested the program, everything's set. We have a G55 work coordinate at 36 or 0, 36, so we're good to go. So rewind, and here we go. So first off is to drill some holes. And then we're going to cut the slots at the back of the fixture, which avoid over constraint when using 2 pins. A hole in a slot and 2 pins is the best way to constrain rigid parts rather than 2 holes and be over constrained. So 1 pass to cut through this 1/4" material. We're running this tool at 18,000 RPMs and 200 inches a minute, single pass. There's the first fixture plate done in 39 seconds. So you can see that if I was wanting to produce and sell these in a lot of volume, this type of work holding approach makes a lot of sense and starts to pay dividends really quickly. If I had tabs on all these things and I had to go and route them off, I would have to be selling these products for a much higher price because of the additional labor involved with yielding a finished part. Because I'm literally setting material on and pressing go and reloading and unloading, it makes the cycle time for the finished product much, much shorter and yields a higher quality part. So dedicated vacuum fixtures, I can't say enough good things about them. I think they're the elite approach, in my opinion, for anybody who's starting to try and make money or that's a small business owner making money with their machine. A little heavier cut right there. And on that last edge, we've already cut that gap. So technically I could do 3 edges, but So we're up to a minute, or up to 2 minutes now. You got these little slots, and then we'll have the profile and we'll be done. All right, there's our finished program. I'm actually going to dust collection off. I'm going to leave the pump running just to demonstrate that these things are still held in place. Nothing moved. They're machined out perfectly. I cannot get these things off at all. But as soon as let's take the dust lid off. As soon as I turn off the vacuum pump and bleed out some pressure, I can simply remove all 4 of these pieces. And if I was making these in production, I would simply load some more stock, press go, and we're making more product. So that's the whole gamut of how you can cut through completely using our product line and our ecosystem. So that's me doing it. I want everybody to see some examples of people in our community that are actually using our product to do similar things, and quite frankly, a lot more amazing than like, you know, a 12 by 12 square with some holes in it. So let's take a look at that. I'm actually going to present this so you can take a look. There we go. And I will slideshow. So the very first example that I thought was worth showing, this is a customer who makes dye sublimation blanks for photos. And he's actually using tile gasket and MDF with a 5 CFM pump, and these are aluminum. So a great application for small parts because there's no porosity, it's super consistent. And he's cutting out all these circles and using them as blanks for sublimation printing. So pretty unique application and a good example. You can tell here that the depth of cut is a little bit much. He kind of uses these as a fixture almost, but very easy to set up because it's a very universal approach. So pretty cool example. If he was really consistently controlling his Z height, you wouldn't see that MDF coming through in the image. It would just be a little etched black underneath there. There's a good chance that could also be a liner on the opposite side, but I'm pretty sure, excuse me, in this case, it's MDF. So that's one of our customer examples. This is that guy that I told you was here yesterday, picked up his system, and he made some fixtures today. So you can see he's actually making these rectangular parts that have some pockets machined on the backside. And he's got these individual zones that allow him to cut completely through on the perimeter, profile the part, and do the pocketing, everything in one shot. And he just removes the material, reloads, and keeps going. So you know, really good example of a simple, direct vacuum fixture. In fact, this section here where he pocketed out each area, you can do, or you can also just face the whole thing and stick the gasket right on top, as long as you know where to place it using your machine and your program as a guide. So he's pretty excited to be up and running so quickly and very interested in making some more dedicated vacuum fixtures for his workflow. This is a longtime customer of ours. Is one of the most impressive examples, I think, of a dedicated fixture that we've seen to date. This is that material called cover gasket that I was explaining earlier. I don't have a demo of this to show you today, but this is a great example of that exact approach. You can see that on top of the fixture, there's sort of a glossy section to the sides, and then there's this strip of cover gasket going down the center. All-Star sells it in 12-inch wide rolls that you can, you know, roll out onto a fixture any way you like. We sell them in sizes that match our vacuum table sizes, our standard sizes. So we sell them in 24 by 24, like I mentioned, and also 24 by 48 for those table sizes. And what he did was very clever. He, of course, engraved his gasket positions. You can see his little zones here on the right and little holes that connect down to the grid for each one of those little pockets. The thing that I love that he did was he made dowel holes, or dowels, put dowels in his fixture, and then used the dowels to hold on to the waste material so it didn't move and potentially knock one of his dominoes loose. So very clever integration, and just goes to show the amount of creativity you can have with these sorts of things, and the different types of work holding approaches that you can combine to get a really excellent result. So, you know, cutting completely through, no onion skin, no tabs, holding onto his stock and making dominoes, which is just crazy, like pretty insane from a work holding perspective in the vacuum world, to hold a part that small that's wood and not like, you know, HDPE or some plastic or aluminum or something like that. That's a pretty hard thing to do. So I'm very impressed with, this is Don's example. And again, that's cover gasket on top of a fixture plate that he customized. And then this is an inboard gasket example, the same approach that I just demonstrated making these 12 by 12 fixture plates that we'll be releasing later on. So, vacuum table installed. You can see this customer's faced their Spoilboard to give a nice clean reference, so a great example of an installation. They've located their vacuum table with pins. They place their fixture plate on, and then they cut this recessed channel and the grid in between and created a port that connects down to the vacuum table underneath. So same approach as our 12 by 12 demonstration we just did. And you can see he's making these cutting boards. And when he turns the vacuum pump on, the workpiece drops down and contacts the surface of the vacuum fixture. And the image on the right, you can't, it's off, so it's not actually flush, but that's the approach that he's utilizing. You can also see that he cut a guide line around the perimeter to help align his work. And as you get more and more into vacuum work holding, you'll start to realize that location can be sort of more general. As long as your stock is oversized and you're overhanging the edge of your known, cut through lines, you're going to yield a finished part. And because of that, you can, like I said before, really minimize your stock size for a given part, especially if you're prepping stock ahead of time. Like if you had, 4/4, 6-inch wide maple or something, and you wanted to really make sure that you're getting, the maximum amount of yield out of some expensive material, you can really start to reduce the required stock size to just barely cut out the part. So really nice advantage. So those are some user examples. I just wanted to demonstrate that because, or show it, because I think that, we've done plenty of videos, live streams, demos, but it's really powerful to see what other people are doing with the product. So a good example there. And those are the examples that I wanted to show. I'm actually going to take this off the stage and bring myself back here. Let's see, where were we? So no tabs. You get the idea. There's a lot of ways to do it. There's a lot of ways to cut completely through your part and yield a finished part. And as always, if you have questions or you're looking for guidance or advice, we're always happy to help. You can email us at info@airweights.com, and we'll get back to you with some recommendations and suggestions and some technical guidance on how to approach your project. Back in stock. So we launched during our last live stream our hard stops, our little machined aluminum hard stops. And they sold out very quickly. I did not expect that take rate. So we're back in stock. We have more. They're available on the website. I can actually show you where they are on the website. So give me just 1 second because I'm doing this by myself. And I want to make sure that I'm showing the right thing. OK, so I'll add this to the stage. So here's our website. If you go to the products page, and you'll see our entire product line here. There's all of our vacuum tables and the various sizes we offer, all of our complete systems. If you go to page 2, our hard stops are the last product because they have not been photographed by our co-founder yet. But they're there. They're available for sale. We sell them in sets of 3. So if you're interested in those, they're a great little tool for repeat locating when you're direct mounting. Now, I just told you a bunch of ways to cut completely through your part with a sacrificial layer between your vacuum table and your workpiece. So if you prefer direct mounting, say you just do a lot of engravings, or you have a piece of like a cutting board that's already cut to size and made really nicely, and all you need to do is just do a little engraving, direct mounting is great. Also, if you have a 2-sided workflow where you're able to eliminate onion skinner tabs on side 2, these hard stops are a great feature, a great product addition, a great accessory, because it allows you to get to the same corner over and over again. So really nice little product, pretty inexpensive, big value add for direct mount users. But the theme of this show is cutting all the way through, and direct mounting, you are required to leave an onion skin to avoid damaging your vacuum table. So just keep that in mind. And then the other thing I want to show you while we're here, if I go back, is we just released some new bundles. So we've been outfitting 4x4 CNCs for a good time now, but it's become more of a need for our customer base. The 4x4 format is becoming sort of the industry standard of the prosumer CNC, the industry size. So we're now offering, in addition to our QCW slat full coverage system for the Onefinity, 3 new bundles that provide full coverage for machines in a variety of different ways. So the first one is our 32 by 32 4-zone bundle. So this is 4 of our 16 by 16 tables. They get mounted to your 32 by 32 machine. It's connected, each one is connected to a manifold, so you have independent control of each vacuum zone or each vacuum table, and that manifold connects to a pump. The manifold has a pressure release valve so that if you're sitting there waiting, you made a dedicated fixture and you pulled vacuum and it's really airtight, you can release pressure, unload parts, and then close the valve and again, turn it back on and work, hold, and start machining again. So the 32 by 32 system is $1649. That's a pretty significant discount over MSRP if you were to add up all of the products. So nice value. We're also selling 2 bundles for the 48 by 48 size. Again, we sell the Onefinity QCW slats. That's 5 slats that go directly into the Onefinity QCW frame. And these bundles are more universal and apply to both Onefinities if you don't have the QCW and a host of different 4x4 machines on the market today. So we have a 4-zone 48 by 48, meaning that it has 4 24 by 24 vacuum tables and that same 5-zone manifold so that each one can be independently controlled. This offering is for that person who wants to be able to isolate vacuum and isolate flow to a smaller area to improve work holding performance on small parts. So if you're the kind of person that's making a lot of products that are not cut from full-size sheets and more like hardwood manufacturing and small parts manufacturing where dedicated fixtures would be appropriate, this is a really great approach to get full coverage and still provides the flexibility of processing full sheets if you need it. The downside is that you have more, a little bit more of a gap between the individual vacuum zones, and in those gaps, there's no vacuum pressure. So just bear that in mind. It's not a big gap. It's a short distance to span, but that's something that provides a lot of control to the user about where they want to isolate vacuum to. So like, let's say you're running 2-sided jobs. You have one fixture on one zone. You can turn it on and then have the side 2 fixture off and turn that zone on and turn the other. There's a lot of things you can do there. We're also offering a 2-zone version, same price. The difference here is that these are 24 by 48 tables. So if you are processing sheet goods all day long, you're processing melamine, you're making cabinets, larger projects, larger signs, things like that. This is the system for you because you're minimizing the amount of gap you have between 2 individual zones. And that allows you to really pull down vacuum over consistent areas and improve work holding where you would, in other instances, have gaps in between. So kind of like a sheet goods processing version and then an individual piece part processing version that's a little bit more flexible. So both are extremely flexible. You can even partition off zones and use our plugs that come with our system to make the 2 24 by 48s kind of function like 24s, but a lot of variety there, lots of ways you can do it. And these are just systems that we've put together for customers so many times. It's just time to offer a bundle. And we're offering, like I said, a pretty significant discount on these compared to the MSRP price. And then again, for any of the Onefinity users out there, we do have the QCW vacuum slat system for the Elite Foreman. And that setup is really, really great for somebody who wants the ability to both use vacuum work holding, but at the same time, leverage T-tracks that are in that QCW frame for other applications where maybe vacuum's not appropriate. So you've got a huge slab of something and you're so bowed and warped and funky that you just can't get the thing to hold. That would be a really great approach if that's something that you do often. So some great new bundles, really excited about these, and just wanted to show those to you all before our Q&A. So let me take that back from the shared screen. And I'm going to actually run through any questions that have come up in this chat. So hang tight. If you have questions, drop them in now. And I'm going to scroll to the top and just start going through these to see if I can see if there's any questions. So I wish I was at the trade show with you, Greg. That would be awesome. Lawrence. All right. Lots of good evenings. I'm not seeing. Okay, here we go. Yes, Braden, a thick boy can put their full weight on our vacuum tables, no problem. We're going to have a video about that actually pretty soon here. Yeah, the new Onefinity machine that got announced today, pretty nuts. DeGray, love the idea for small parts. That solves a major headache currently being faced over here. Some HDPE parts that I hate having to tab. Yeah, so the cover gasket approach, if you have small HDPE parts, is like totally perfect. 10 out of 10 recommend. Scott, about to upgrade. Don't forget, we have that. If you really are serious about upgrading your CNC and you're interested in AirWeights, we have that sale running right now for the live stream. It's going to go until Sunday at midnight Pacific. So pretty much as long a time as we could give you. And the discount code is NOTABS10. I'll actually put it in the chat here. I just don't have a way to do a ticker. I mean, I do, but this is easier. So there's a discount code. If I only had the cash, this would make my life easier from Burning Tree Productions. Maybe you're going to win tonight. Maybe you're going to win. Are there going to be new fixtures for the 4x8 Onefinity just announced? Yeah, Braden, I think that there has to be. We haven't quite got there yet, but it depends on how things shake out with that machine. But obviously we'll have a solution for them no matter what. Yeah, they can keep their T-track all in on vacuum work holding. I'm glad to hear that. DeGray, do the vacuum pumps require any regular maintenance? Good question. The answer to that is very simple. There is actually an inlet filter on all of our pumps. It ships with every single one. There's one on this one down here. That's the 17. That little inlet filter is really similar to the one you would see on an air, connected to an air compressor. It's just to knock out particulate and any moisture. And the major thing that you need to make sure is that you have the arrow on that inlet filter pointing into the pump in the direction of flow. And that periodically, I'd say every 80 to 120 hours of use, you unscrew that filter, knock it out, clean it out, and then screw it back on. The filter that's sold with our 9 CFM pump actually isn't threaded, so you can just kind of like twist and pull, and it just kind of seals with an O-ring. One of the things that's really cool about vacuum is it's self-sealing. So the pressure difference is creating force out to in, and so you don't really need threads to seal it or hold it in place. It's being held in by pressure. So pretty cool little feature on that one. But the 17 and the 5 sell with a filter that threads in and out. Other than that, no real regular maintenance. These are relatively maintenance-free. There are wear parts, but they take so much use and so long to wear. I don't think that any of our users would ever see that amount, even with a continuous duty cycle. So there's no real true maintenance that needs to be done other than just emptying that filter canister. The other thing that I mentioned to a customer recently is, our pumps get very hot. And that's something that you need to be aware of as a woodworker. If you're producing a lot of fine dust near or around your CNC, I'd hope that you're making chips and not dust with your machine. But if there is a lot of fine dust in the air that's settling on the pump, when it's off and it's cool, make sure you keep it clean. We don't want anybody running into any safety issues. And just make sure that it's clean and that the filter is clean, and you should be good to go. Very important question. I do not know, Braden. I do not know how I got to be so cool. Maybe because I used to make fins for surfboards. A little off topic. Has anyone used just the pump to double as a way to do vac glue ups? Very good question, Dan. We have people that are using our pumps for veneering and basically forming guitars, so guitar bodies. They definitely work in vacuum bagging applications. And the caveat there is that our pumps are set up to be run continuously, meaning that there's no auto cycling happening. A lot of the pumps in that industry focus on achieving a certain level of vacuum and then shutting off and making sure they're maintaining that every so often as needed with a certain threshold. In our case, auto cycling can be a safety issue, so we prefer that the user just keeps it pinned and lets it run. So there are some solutions out there that allow for auto cycling. However, it's not something that we offer yet. All right, Lawrence. Good to see you here, Lawrence. I had a cover gasket fail because I made the cover gasket outline only 1/8 thick around the edge of the pieces. A 1/4-inch cover gasket strip around the edge of the piece is preferred, right? Yes, so you really want to think about this in terms of like aspect ratio. So if you remember that example that I showed of those dominoes, he had a very, very thin gasket. Another thing that's important to note about gasket is if you're going to cut it really thin like that, you really should apply pressure. All of these adhesives are pressure sensitive, just like most adhesives. And if you push on them, then you help seat the seal. So a lot of times what we do when we make fixtures here is we make our fixture and then we put a piece of smooth, flat, non-porous material, just like the same stuff we have around, on top of our fixture, turn on the vacuum and let it sit under pressure for about 30 minutes. That's way overkill, but you can use your vacuum fixture to help reinforce the bond between your gasket material and the surface. I also note that the higher the surface energy, the cleaner it is, the better the bond you get. But in general, there's always a balance between the width of your gasket when you're using cover gasket and the size of your part. So it's really going to be dictated mostly by that. If you can get out to a 1/4 inch and still have enough of a vacuum pocket on the interior of that zone, by all means. If you're making something down to the 1 inch by 2 inch size, like those dominoes, or we have a customer that once made, HDPE keychains, like King Color Core 3-tone, and they're like 3/4 of an inch by 3 inches long, super tiny. And you just want to make sure that you're maximizing the width while still you have to optimize between the width of your gasket and the zone that's left on the interior of that. With some part sizes, if you have a 1/4 inch wide gasket, you're not going to have any vacuum zone in there. So make sure you're getting a nice strong bond to your fixture, and then also just balance as best you can, sticking to a 1/4 inch unless your part's too small, and then back into a size that works for you. All right, Braden. Just because you ran into it, should I be doing this? Just because you ran into it, can you explain if it's possible to go through MDF only? And what sort of stipulations in terms of material and setup need for that to work best? Yeah, so the key here when you're using MDF by itself, smooth, flat, non-porous. Those are the 3 requirements for your material. Think melamine, think pre-finished plywood, think plastic sheets, think aluminum sheets, those types of things you can get away with running on a bare Spoilboard, especially with our highest flow pump, a 17, and covering the whole thing completely. So those are kind of the stipulations. If you're cutting typical plywood, not a thing probably. You probably need tile gasket. If you're cutting MDF, also probably not a thing, just because that's the material that's leaking as your Spoilboard, and then you're putting another leaking material on top. You get the idea. things like end grain are like the enemy of vacuum, because it's just straws literally going through the material and it just breathes. So there's no pressure difference established. So yeah, I think for the majority of people, I highly recommend purchasing tile gasket for processing sheet goods. It's better work holding. You can control your Z heights, you'll get great service life, and there's a lot of benefits there. If you're pretty savvy with vacuum work holding, you've been doing it for a while, you want to experiment, your parts are relatively large, try a bare Spoilboard. But again, it has to be so smooth, so flat, so non-porous. It's got to be things like Bamex, melamine, plastics, that sort of thing in order for it to be successful. So TP Sooner, so are the gaskets the primary consumables needed to run the AirWeights? I would say there's two primary consumables. One is gasket material. If you're making dedicated fixtures, I wouldn't really consider it a consumable, just because you can use that fixture for as long as you have it. You know, you make it once, you put in the work, you put in the time, and then it works for a very long time. One thing to watch out for is compression set. The gasket materials that we source rebound extremely well, and they're designed for this application. But other materials out there, the main difference is that they don't always come all the way back. So you could design for a certain percentage of compression, and then over time, with other materials, the gasket just kind of starts to settle into a compressed state. Our materials can be used over and over again and rebound much more effectively, well, I should say All-Stars materials, than something you would just go buy at the store that's weather stripping or whatever. So purpose designed for that. Tile gaskets are a consumable. Onboard, inboard, and the nested gasket squares can be somewhat reused. Grid gasket is a good thing to, you know, All-Star recommends servicing it every so often. That's usually on industrial machines, and we haven't seen compression set so much with ours. So Spoilboards, fixture plates, and some gasket materials, I would say, are the primary consumables for our product line. All right. Are there any benefits to going with a larger compressor offered even if a smaller vacuum fixture? Bigger is better. The answer is yes. So like in this demo, I was energizing 2 tables off a 17 CFM pump. You can get the full work holding capability of our entire line running a full 4x4 machine off of this same 17. But if I turn off 2 zones and I'm just isolating all the flow to those front 2 positions, all of the work holding power is going just to those tables. So that's the advantage of having that external manifold. And a lot of customers will actually choose to upgrade to a larger pump with a smaller table just because they want that added insurance of flow rate. They want to be able to make more stuff and not worry so much about leaks. So the performance of running a 24x24 table versus running a 24x24 with a 9 CFM is dramatically improved, just because you have that much more flow rate if you're downdrafting. When you're making dedicated fixtures, it doesn't really matter, because all that matters at the end of the day is the ultimate vacuum that you're reaching, the pressure difference times the area. So if you're not downdrafting and you're making dedicated fixtures, you can actually get away with a really tiny pump and get extremely rigid work holding, which is one of the advantages of spending the time to make a fixture. But if you're into downdrafting and that's your thing, and you just want to, you know, have the experience of running an industrial machine while still saving some money, but maybe spending a little more than you would just buying our standard systems, that's definitely an option. And we see a lot of customers going that route. So I hope that answers that. What do we have to do to enter? It's coming, Coda. Hang on. We'll get to the giveaway after the Q&A. Greg Bennett, what is the max negative pressure of the 17 CFM vacuum pump? Great question. The maximum ultimate pressure is minus 24.5 inches of mercury. So that's pretty darn deep compared to, say, you know, a high flow rate equivalent that's out there. That high flow rate equivalent will produce, you know, hundreds of CFM, but it'll never get to very deep vacuum. So, you know, dedicated fixtures and things like that, you're limited more, and you won't get as strong a work holding. Downdrafting, you'll get a better experience because it's more universal. It can account for more leaks. So that's kind of the trade-off. But yeah, Yeah, the max negative pressure is minus 24.5 inches of mercury, which equates to, like I use 10 psi as a rough number for calculating work holding force, just because it's an easy thing, but it's closer to 12 or a little bit more than that at the end of the day. So all good, Coda. So any more questions? If there is any, I'm happy to answer them now. And if not, I can jump into our live stream. I can jump into our giveaway. A little tired. So last thing I want to remind you before we do the giveaway, if you don't win the giveaway, we still have a discount code for you. I put it in the chat. I don't think I can do, let's see, maybe I can do this really quick. No. Gosh, this is terrible. What's up, Zach? No tabs 10. So there it is. No tabs 10 will get you 10% off now through this coming Sunday at midnight Pacific. So plenty of time to use it, and good time to pick up something. It's a great deal. With some of these new bundles that we're offering, those will be some of the most heavily discounted sales that we've ever had. So excited to be offering that. All right, if there's no more questions, let's go to comments. Yeah, Barrett just joined. This is going to be recorded, so you're welcome to go back and watch. But basically, the system that we showed was all these different approaches for cutting completely through your stock and leaving a finished part when you're done. We have vacuum tables underneath this, and so you can see, like if I take this off, vacuum tables underneath here. These are our flagship product, our 24 by 24 vacuum table. I have them all hooked up to a pump via these manifolds, and I have some dedicated fixtures on here that allow me to cut completely through outside of these gasket zones, leaving a finished part when I'm done. We also talked about using spoilboards for that, so make sure to go back and watch the recording to see what the benefits and drawbacks of those are. And it'll all be recorded, so you'll be able to go back and see it once we wrap up. Coda, great question. How do you align the 1F tables to make sure all are in a row for using 3D printed fence tabs? So great question. On the top side of our QCW slats, let me see if I can grab one really quick. Yeah, so here's a slat. And you can see that on the top side, there's some locating holes machined into the top surface. And the process is each slat has a 1.5 inch long 1/4 inch dowel in the hardware kit. So you roughly position these on your machine, kind of where you think you want them. And then there's a DXF on our website that shows the default layout for how these are positioned relative to the QCW frame and relative to your machine home. So you basically bring the machine over with the 1/4 inch dowel and the spindle and lower it at a known position until you interface with one of these holes. And then on the underside, you'll shoot a screw into these slots that line up with the holes in the QCW. They can be shifted forward and back. That's why we have slots to account for things like the QCW rail accessories, like the ATC mount or the tool setter mount, et cetera. So you can shift them back a little bit, and that you can adjust the DXF to your liking. But basically, use the spindle to drop this in, pop the screw in the bottom, jog back in the Y direction, lower the spindle into another pin, and then with it in there, shoot a screw in, then you can come back and check. And you repeat that process for each one, and then the slat is basically squared to your CNC machine. So that's the process. It's a little bit cumbersome, but once you're done, you're done. And that's just a one-time thing. All right. Glad I could help, Barrett. All right. So any last minute questions, throw them in now. And in the meantime, let's start our giveaway. So tonight we're going to be giving away a 24 by 24 vacuum table and a 5 CFM pump. So that's our 24 by 24 complete system. It retails for $749 right now on sale. If you win and you would like that credit to be applied towards something else, we're happy to do that. We can just issue you a gift card. You know, there's a lot of existing customers, people that have come before. So we'll work with you to get you whatever you need in our line, given your machine, your setup, your configuration. So we're going to go ahead and start this. Let me just bring up the giveaway. All right, so the hashtag that you need to enter into the chat to be entered into the drawing is #NoTabs. So place that in the chat and we'll give some time for people to enter. I bet there's not very many people on here, so we'll probably have a really good chance of winning. And all right, we're up to 4 entries. We got good odds. So in the meantime, like I said, if anybody has any questions, please feel free to drop them in. I appreciate everyone joining tonight and some of you that are familiar faces adding some banter. Yeah, Greg, if you're still on there, let us know how it is over there at AWFS. Would really love to hear some of the stuff that's going on in Vegas. Wish I could be there. Had planned to go, but had some things come up and wasn't able to make it. So yeah, just happy that there's some of our products represented there. I know All-Star's there with our systems demoing all their gasket solutions for all sorts of different, CNC router operators, and also Onefinity's there. Hopefully there's some slats on one of the machines. What's your favorite podcast? Well, I have one pretty favorite podcast that I listen to pretty often, and I really like these guys. They're just kind of crazy, But if you haven't listened to another Woodshop podcast, you better go check it out. Anyway, 28 entries. Man, those are some good odds. I just can't believe more people don't come to this. Jerry, I wish you could charge less for shipping to New Zealand. Send me an email, man. Email me at info@airweights.com and we'll see what we can do. I know it's kind of a pain, but yeah, I would love to have some distribution. I don't know how to say this. Djonix. Thanks for the streams. Really fun to be able to interact. Yeah. I love doing this. I think it's so fun. I think it's a great way to interact with the community and also just provide more knowledge so that people can get the most out of their products. I think it's something that comes really second nature to me, given the experience and using it in industry and, helping businesses leverage vacuum for holding small parts in a pretty inexpensive way compared to, an industrial vacuum table. So it's just, I want to share and give back, and this is a great way to do that. Like I said, we'll be putting out more videos that detail some of these processes and provide step-by-step instructions for how you can achieve great results on your machine and your setup. So yeah, just a lot of things to cover and a lot of knowledge that's important for people to understand if you want to use your system as best as possible. So anywho, 28 entries, 28. Anybody left? Anybody else? Any no tabs out there? If you're just joining and you didn't see, enter #NoTabs into the chat for your chance to win a 24/24 complete system. All right. Going once, going twice, and I think it's going to be sold to whoever the winner is going to be. Where's my mouse? There it is. Okay, here we go. Dun, 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 dun. Oh. Dan. Dan Massetti, all right. Hey, congratulations, man. Woo! So Dan, all you need to do is head over to our website, find our contact form, and just enter in the subject, live stream winner, July 2025. And we will work with you to get whatever setup you need. Either apply this credit towards a system or just give you the 24x24 system if that's what you feel like you want. So yeah, head over to our website, submit the contact form, or you can just simply email us at info@airweights.com and we'll get you dialed in. So congrats, Dan. Thank you so much for joining. And nice odds. I got to say again, like 28 people. I mean, yeah, people should just not go to AWFS in Vegas this time around and come to our live stream, and you probably win a lot more. So thank you, Dan, so much. Please email us and we'll get you hooked up. And with that, let's see, any other things? We appreciate all the comments. I'm glad you guys will be rewatching and that you appreciate the examples. If there's anything that you really feel like you want to know or understand more about, please let us know. Send us an email. We're happy to take input from the community and roll those into ideas that we could demonstrate for you all. Different types of example parts, different types of applications, different approaches, whatever it is, let us know. You can also comment on this video and let us know. We're pretty active and taking note of what the community is saying about our products. So yeah, always rolling in feedback, always coming out with new features. We have a lot of new products coming out between now and the end of the year, some accessories, some really exciting new things that I think will really improve people's process and experience of using the AirWeights ecosystem. So thank you so much. Thank you to everyone. Dan, congratulations. And with that, I think we're going to wrap up. And if you guys are ever so kind, could you please just subscribe to our channel? If you're watching this and rewatching it, subscribe. If you found it valuable, subscribe. If you want product updates related to our latest offerings and new releases, you can subscribe to our email list, like I mentioned. And grateful for this community, grateful for you all. Thank you so much, and we'll see you in the next live stream. Take care.